Question of the Week from the Naked Scientists.
Hello, this is Question of the Week with me, James Titko. This week's question comes from listener Christoph.
Why don't plants freeze to death during winter?
A great question. The stakes are high for plants in the winter, which are desperately trying to avoid ice crystal formation and the subsequent disruption of vital cellular functioning. To explain exactly how they avoid succumbing to a frosty grave, this week's guest is Howard Griffiths, Professor of Plant Ecology at the University of Cambridge. Over to you, Howard.
Plants from cooler temperatures have a number of mechanisms which allow them to get used to lower temperatures. As winter approaches, their metabolism adjusts and plants become hardened to the cooler conditions during autumn.
And how do they do it?
Well, to avoid chilling damage, plants change the composition of cell membranes and incorporate shorter, unsaturated fatty acids, exactly the ones that are good for us. These changes prevent the membranes from becoming more solid or gel-like and help to maintain normal metabolism.
So, eating your greens is even more beneficial in winter due to the plant's anti-chill techniques, a silver lining to those endless grey clouds. But what about freezing?
In order to avoid damage from ice crystals during freezing, many of our plants shed their leaves in winter, becoming deciduous. For the plants which keep their leaves, they can tolerate freezing temperatures by supercooling, which can protect plants down to about -12 degrees centigrade. This prevents what's known as nucleation, the first step in ice formation.
Supercooling, nucleation. You'd be forgiven for thinking these were processes going on in some sprawling thermal power plant. But this is all going on inside the most ordinary plants we encounter every day.
It's essentially the same thing as when we add antifreeze chemicals to our car radiators and salt to de-ice roads. These solutes help to lower the temperature at which water freezes. Plants also accumulate extra solutes in their tissues and can make specific antifreeze proteins or cryoprotectants which prevent ice formation and help to lower the freezing point of cell tissues.
That's why you shouldn't walk over a lawn while the grass is still white with frost. The grass underfoot may be supercooled, with your clumsy steps disrupting this delicate process, causing ice crystals to form and putting an end to the poor grass's resistance.
Exactly, and other plants like conifers, which survive extreme temperatures in Siberia and northern Canada, have thickened cell walls and repackage proteins and pigments to prevent damage, and also can tolerate deep supercooling down to -40 degrees C.
As seen on TV, David Attenborough covered the boreal forest at the start of episode 3 of The Green Planet if you'd like to see these amazing trees for yourself.
Indeed, and these processes have added benefits for humans as well. Maple syrup, for example, is made from sugar solutions which maple trees use to repair and refill their water transport cells, xylem, after surviving a long, cold winter.
The sweet taste of victory. Well, Christoph, I hope that answers your question. Plants have a few ways to beat the chill, from changing the makeup of their membranes by incorporating shorter, unsaturated fatty acids, to lowering the temperature at which water freezes within them via additional solutes. It's all rather remarkable, isn't it? Thank you to Professor Griffiths from the University of Cambridge for helping us with this question of the week. Next time, we'll be answering Sal's question.
Is the behaviour of school students affected by moon phases?
If you have any thoughts on what we discussed today here on Question of the Week, please tweet us on @NakedScientists or log on to the forum on the website to join the conversation. If you've got any questions yourself that you'd like us to tackle, please send them by email to chris@nakedscientists.com.
Question of the Week is part of the Naked Scientists podcast and supported by the Wellcome Trust and UK Fast. Look us up online at nakedscientists.com.